Hi there, this is Kira, and today we will be working through simultaneous equations. I will be continuing the Mathematics Paper 1 from November 2021. It is a DBE past paper. Today I'll be focusing on question 1.2 and question 1.3. Question 1.3 is not a simultaneous equation, but it is one of the more difficult, high level questions that they ask in question one, which is the equation section. They always ask a question like this, and there are many different types of questions they can ask. But today I would just also like to focus on the different kinds of problem solving techniques we can use to approach a question like this. I'm going to begin with the simultaneous equation. Okay. So when you learn simultaneous equations, you probably will be taught several different methods you can use to solve simultaneous equations. I believe that the best method that you can use is the substitution method. And the reason why I say that this is the best method to use is because it applies to any type of equation. No matter the situation, you can always use the substitution method. All right. So the first step, I'm going to write us some steps about to help us approach these questions. The first step is to identify the simplest form of X or Y. Once you have done that, isolate X or Y in that equation. I'm going to call this equation 1. Then you are going to substitute this isolated form into the second equation. And then you are going to solve and then resubstitute into equation 1. So this kind of broad steps we'll be following. It might not make a lot of sense now, but it'll all come together with the example. Okay. So the first thing I want to say about simultaneous equations is that the problem with simultaneous equations is that instead of having one variable in the equation, you now have two sets of variables. So you need to come up with a strategy. Since we only know how to solve equations with one variable in them, this strategy is going to allow us to form equations with only one variable, which we can then solve. So the first step was to identify the simplest form of X or Y. If I look at the first equation, I have 2y plus is equal to 3 plus x, and 2xy plus 7 is equal to x squared plus 4y squared. Now, in these two equations, the simplest version or form of x of y would be x. Do you see that it would be very easy to isolate x in this equation? It would not be as easy to isolate x here or here, and it would not be easy to isolate y over there. Alternatively, you could isolate y in this equation here. All you would need to do is divide out by 2. But I like to take the simplest approach. And in this case, it's x. I just need to move that 3 over to the other side. So what I like to do when I begin these equations, just so I keep track of everything, is I like to start by writing equation 1. Oh, sorry about that. That doesn't look very nice. equation 1. And here, your equation 1 is always going to be the equation with the simplest form of x or y, where you're going to isolate a variable. So that is actually the first equation. 2y is equal to 3 plus x. Okay. Now I'm going to go straight ahead and isolate x. Okay. So to isolate x, I just need to take that positive 3 over the equal sign, and it'll become negative 3. So now I get x is equal to 2y minus 3. Okay. So I have now completed step 1 and step 2. I've also labeled it as equation 1. Okay. Now, on the other side of my paper, and I'm going to use a different color as well, I will write equation, I'm just going to abbreviate it to save some time, equation 2. I'm going to write out the equation as I see it here, okay? Just so that the marker can understand what I'm doing. If I go straight into substituting, the marker might be confused, and I might even confuse myself and make a silly mistake, which I definitely do not want to do. Okay. So I've written out the equation. Now, I have an isolated form of x. X is equal to 2y minus 3. Therefore, I can substitute this in the place of x throughout the equation. I'm going to do that now. So, and I use brackets whenever I substitute. Otherwise, I will make silly mistakes. Okay, so in the place of x here, I'm going to write 2y minus 3. And then this is multiplied by y. But to make it look a little bit nicer, I'm going to move the y out to the front here. Okay. Plus 7 is equal to, it's a bit long, is equal to, now I've got another x. So it's x squared. So I'm going to write out 2y minus 3 squared. Okay. And then let me just move this over, give myself a little bit more space, plus 4y squared. Okay. Excellent. Now I need to solve and simplify. I've done the third step, which is to substitute this isolated form into the second equation. Now I need to simplify. Okay, so I will distribute the 2y into this bracket. Let me zoom in slightly. Okay, so I will get 2y multiplied by 2y is 4y squared minus 2y times minus 3, it gives me minus 6y plus 7. Okay. I need to FOIL this expression out. It is very difficult to FOIL it when there's a square there. It's very difficult to FOIL when you don't have two brackets multiplied by each other. Okay. So to help me FOIL correctly, I'm going to write out the square like this, 2y minus 3. Okay. So to FOIL this out, I have 2y multiplied by 2y, which is 4y squared. Then 2y multiplied by minus 3, which is minus 6y. Then minus 3 multiplied by 2y is minus 6y. And minus 3 times minus 3 will give me positive 9. Okay, and then all of this plus 4y squared. Now, at this point, I'm still trying to solve this equation. I can see lots and lots of like terms. So I'm going to, first of all, simplify on either side of the equal sign. Because when you have a lot going on either side of the equal sign and you want to simplify, I actually find it's better if you simplify first on each side of the equal sign and then take everything over to one side, because you want to avoid making silly mistakes. And if you have too much going on, you are more likely to make a silly mistake. Okay, so here on this side, I can't simplify. There's no like terms here. So I'm just going to copy and paste that down here. Okay. Then on the left-hand side, I see that I've got a 4y squared plus a 4y squared. So that is going to give me 8y squared. And I've got a minus 6y, a minus 6y. That is going to give me minus 12y. I just want to take stock quickly that I've included all the terms in my calculation. Taking care of that 4y and that 4y and that minus 6y and that minus 6y. All that's left is the 9, and it doesn't have any like terms. So I simply say plus 9. Okay. It's pretty clear now that we have a quadratic equation. So we need, from my previous video, I spoke about my strategies for solving quadratic equations. And my first step was always the rule of 0, which means that you need one side of the equal sign to equal 0, or one side of the equation to equal 0. So I am going to move all the terms on the left-hand side over to the right-hand side to get 0. So I'm just going to rewrite the right-hand side first, or actually, let me just copy and paste to save some time. Okay. Okay, we just got a few extra y's that hopped along, which I'll get rid of. Okay, now I take the 4y squared over, so it becomes minus 4y squared. And I take the minus 6y over, so it becomes plus 6y. And the plus 7 becomes minus 7. I just want to quickly check that I've done all my signs correctly. Now I have like terms once again. So what I'm going to do is I'm going to simplify, add all my like terms together. Okay, so I've got an 8y squared and a minus 4y squared. Those are my only terms with a y squared in it. Okay, 8y squared minus 4y squared gives me 4y squared. So I'm taking care of those two terms. Then I've got 12y. The matching pair here is the plus 6y. That's the only other term with simply a y, the coefficient multiplied by a y. Minus 12y plus 6y will give me minus 6y. And then, so let me just tick off that I've taken care of those. And then finally, my constants remain. So I've got plus 9 minus 7, which is going to give me plus 2. Now, I'm ready, almost ready. Well, at this point, it looks like I'm ready to factorize and solve. But before I start factorizing, I see that I've got my y squared. My squared term has a coefficient, and that is quite annoying to factorize. So if possible, see if you can divide out by that coefficient or a factor of that coefficient. And I can actually see that all of my terms are even. So I can, or the coefficients of all my terms are even. So I can divide out by 2. Okay, just to make my life a little bit easier when I need to factorize. You don't have to do this step, but it will make the factorization a lot easier. Okay, so this becomes 2y squared. Oh, sorry. Okay, 2y squared minus 3y plus 1. So definitely going to be much, much easier to factorize. Okay, so because I have 2y squared as my first term, I must have 2y as the first term in the first bracket, and then y as the first term in the second bracket, because when I multiply these out together, if I were to FOIL it, it would give me 2y squared. Okay, then my constant is 1. So, and the factors of 1 are 1 and 1. Just a little side note while we're talking about it. 1 is actually not a prime number. 2 is actually the smallest prime number that exists. Anyway, so now we know that our second terms in each bracket must be 1, because these last terms will multiply with each other if we were to FOIL to give us this plus 1 at the end. Now we need to work out how we are going to get our middle term of negative 3y. Well, I've got a plus 1 over there, which means that the signs in my brackets are either plus plus or minus minus. Okay? And because I have a negative 3y in the middle, it's very clear that I must have minus minus. I can check my factorization quickly. Always a good thing to do. Okay? I can check it by foiling out. Okay? You want to do this on a piece of paper on the side or in pencil at the bottom of the page as to not confuse yourself later. Okay, so if I FOIL this out, 2y multiplied by y will give me 2y squared. 2y multiplied by minus 1 will give me minus 2y. Minus 1 multiplied by y will give me minus y. Minus 1 multiplied by minus 1 will give me plus y. And it's very clear that that middle term will become minus 3y as required. Okay, so let's get back to the problem at hand. Okay, so now that I've factorized, I can split each bracket off and set it equal to 0, and then solve for y. So 2y minus 1 equals 0, or always remember to put or in between your solutions of a quadratic equation. Okay, and then I simplify by taking the minus 1 over, it becomes positive 1. Then to get y alone, I must divide out by 2. So I get that y is equal to a half. Or, oh, I forgot to say that this has to be equal to 0. And then I just take the minus 1 over and I get that y is positive 1. Okay, so those are our two solutions for y. Unfortunately, we've only half solved the problem because this equation was in terms of x and y. So we've done up until question 4. Now we need to resubstitute into equation 1. And what I mean by that is to get our x values, we are now going to substitute our y values in. We have to be very careful because we have two y values, which means we will get two x values. So to avoid any confusion, what I like to do is I like to consider I have to consider the first y value first. Okay, so that's y is equal to a half. Right, this thing seems to have frozen. Okay, so I like to say for y equal to a half. Okay, then I substitute y into this expression for x. X is equal to 2 multiplied by a half, because y is equal to a half, minus 3. Now 2 times a half is just 1. And 1 minus 3 is minus 2. Great. Now I need to find the x value for which is associated with my other y value. Okay, which is y is equal to 1. Okay, for y is equal to 1, we know it's x is equal to, let's just double check, 2y minus 3. So 2 times 1 minus 3. So 2 minus, oh, that's not very clear. Let me rewrite that. 2 minus 3 will give me minus 1. And then if you just want to write your solutions out nicely, I like to say, therefore, y is equal to a half, or y is equal to 1. And then I like to write this associated x values underneath. So this was associated, that y is equal to a half was associated with x is equal to minus 2, and y is equal to 1 was associated with x equal to minus 1. So finally, we are done solving our simultaneous equation. This was a lot of work, but the question is for 6 marks. So it is well worth the work. I think it's important that you take some time to practice simultaneous equations, and I will attach a few examples below. Here are some examples of simultaneous equations from the Siabula online textbook. Please pause the video and copy these examples down and try them by yourself. For the first and second equations, I've given you the solution. So hopefully that will help you practice this section. Now we are going to move on to question 1.3, which focuses on nature of roots. They often ask this question, so it is very important that we understand and can apply these principles. Alrighty. So upon first glance, this question sounds almost impossible. The roots of an equation are given by x is equal to negative n plus or minus square root of n squared minus 4mp all over 2m, where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. Now, this is the type of question that looks incredibly scary, and a lot of students will not even try and attempt. I promise you, it's not that difficult if you break it up into small steps. Now, I must say, even when I read this question, the bit about the geometric sequence freaked me out a little bit too. But that's why I'm going to actually focus on the basic principles of nature of roots before, and then take out the bit about the geometric sequence, and then we will add in the bit with the geometric sequence. And you'll see when I break it up like that, it's going to be much easier. Okay, so let's talk about nature of roots. So when I talk about roots with nature of roots, I'm not talking about square roots or cube roots. We actually call these things surds. We should not actually call them roots, okay? A root is actually an x-intercept or the solution of some equation involving x set equal to 0. Okay, so that is what a root is, okay? I don't think that this equation is easily solvable. Let me have a quick think. I'm actually going to make that plus 7, and then I'm going to change this to be 8. Okay, so don't worry about too much about how I solve this equation, because that's not really our focus here. But the values for x we get for this equation are x is equal to minus 7, or x is equal to minus 1. And these two values of x are what we call the roots. So how you should think about these nature of root questions is it's like the nature of maybe solutions should be how you think of it in your head, okay? But you do need to be comfortable with this term roots because they are going to use it in questions. And I'm pretty sure that's how the terminology your teacher would use because that is the official terminology for these values. Okay. Oh, whoops. Oh, okay. So, oh goodness. Okay, I just want to try and figure this out. Okay, there we go. Right, so those are our roots. Now, what I'm going to use to explain this nature of roots question is actually the quadratic formula. We can apply the quadratic formula to any quadratic equation involving x to find the roots of the equation, the solutions, the x values. Okay. Okay, so this is our quadratic equation. And recall from last time, A, B, and C refer to A is the coefficient of the x squared term. B is the coefficient of the x term, and C is the value of the constant. Okay. So this is the quadratic formula, and we can apply this to any quadratic equation. But the quadratic equation has to be set equal to 0 before we solve this. Okay. Now, when we talk about the x solutions or the roots, we have three options for x. X can either be real, or actually, hold on, non-real. X can be non-real. X can be real. Well, the x values can either be unreal, or the x values can be real and unequal, or these roots or x values, x solutions can be real and equal, i.e., we only have one root. Don't worry, I'm going to explain this concept. Okay. First, so these are your three options, and I would really like you to write this little summary down. Okay. First things first, when we talk about the idea of a real or a non-real number, okay, a non-real number is a number that does not exist in our traditional understanding of mathematics, i.e., it is numbers that you pop into your calculator that will give you an undefined answer or a math error in the calculator. So this happens when we divide by 0, or if we take the square root of a negative number. Now, if we look at our quadratic equation, do you see that we have a square root here? We have stuff under the square root here. And we could get non-real x roots, solutions of our equation, if this quantity is negative, if it is less than 0, okay? You might also be thinking that because we've got a fraction here, if this was equal to 0, then we would have a non-real solution of x. But actually, we never consider that, because if a was equal to 0, right, which would make the denominator equal to 0, then this term here would fall away and we would not have a quadratic equation. So we would not be eligible for the quadratic formula, or to use the quadratic formula. So actually, all we are thinking about with nature of roots All that really matters when we need to think about, are our equations real, non-real, are roots equal, are they equal? All that really matters is this, what's underneath the square root. So we will be analyzing this. I will also substitute it into the quadratic equation to show you the relation. Okay, so for non-real roots, I'm actually just going to start there because that is very easy. We need to have, to get non-real roots, we need the bit underneath the square root in the quadratic equation to be negative, i.e., it needs to be less than 0. So b squared minus 4ac must be less than 0, i.e., negative. So that will give us non-real roots. See, that's the bit under there. It'll be non-real roots, and you can even write this here, because you will take square root of a negative. Okay, so then the next one is if we have real and unequal roots. So in this case, to have real roots, we will need to have this greater than 0. So the opposite really of non-real roots. As long as the bit underneath the square root is positive, we will have real roots. Okay, that is what you need to remember. You might be wondering what I mean by unequal roots. Okay, what I mean by that, because sometimes it might seem like the roots are equal. If I have an equation like x squared minus 4 is equal to 0. Okay, if I solve this equation, I will factorize and I'll say this is dots, so x is equal to minus 2. X minus 2 multiplied by x plus 2 is equal to 0. If I split and solve, I will get that x is equal to positive 2 or x is equal to negative 2. While these solutions are real because they are integers, okay? But while the intrinsic value here of 2 is equal, these roots are not equal because one is positive 2 and one is negative 2. So this equation falls into the real and unequal roots case. When we talk about having equal roots, that means we actually only have one root, okay? So, but it's a real root, okay? We have considered the bit where, or the part where the bit underneath the square root in the quadratic equation is less than 0 and greater than 0. But have we thought about what happens when it's equal to 0? Well, if I go back and I look at my quadratic equation, if the bits underneath this square root b squared minus 4ac, if that is equal to 0, then this whole thing will be equal to 0 because the square root of 0 is 0. And we will have negative b plus or minus 0, which is just negative b over 2a. So do you see, if the bit under the square root is equal to 0, we actually only have one root. Okay, and one root is the same as two equal roots. Okay, so that's what we mean in this case. Okay, it's quite easy to remember because now we've got three scenarios. Okay, one quantity, three scenarios. B squared minus 4ac when it's less than 0, b squared minus 4ac when it's greater than 0, and b squared minus 4ac is equal to 0. Okay, and in each case where this quantity has different value, we have a different scenario. We have a different solution for our roots. Okay. I'm now going to take us through a series of short examples before I move on to a more complicated question. Okay. So let's consider, I'm going to make my own question. Consider the roots. Okay, let me actually write it like this. Equation x for me. Equation Okay, so we now have got our equation. So now I'm going to ask us, for which values of B will we have? Okay, first scenario. Equal roots to unequal real roots, and finally C, no real roots. Okay. So now, to evaluate this question, all we actually need to know is the value of b squared minus 4ac. Okay, so I will compute b squared minus 4ac. Okay, so let's do our answer. Okay, so b squared minus 4ac in this case, okay, b is equal to b. That was intentional. A is equal to 1, so that substitute in 1 in the place here, and C is equal to 9. Okay, so we see that we have b squared minus 4 times 9 is 36. Okay, now I will consider the different scenarios. To have equal roots, do you agree we need to have that b squared minus 4ac is equal to 0? So I'm going to set the b squared minus 4ac in this case, which is b squared minus 36. I'm going to set that equal to 0. Okay. If I factorize and solve, I will have, this is dots, so it's b minus 6, b plus 6 is equal to 0. Okay, I split and solve, not 36, sorry, plus 6. I split and solve, so I set each bracket equals 0. Okay, b plus 6 is equal to 0. And if I solve, I will have b is equal to 6, b is equal to minus 6. Now for the case where I have two unequal but real roots, I need b squared minus 4ac to be greater than 0. So I will solve the inequality. I said b squared minus 4ac, I said that has to be greater than 0. In my previous video, I discussed how to solve quadratic inequalities. Okay, I've just solved this equation, so I have my CVs, which is b is equal to plus or minus 6. Now I set up my number line. Okay, minus 6 comes before 6. And I will have an open dot because I'm not including. And then I always have plus, minus, plus. Okay, in this case, we are greater than 0. So I will be looking in the plus portion. So I draw in my arrows. Now I write x is less than 6 because I copy the direction of the arrowhead. If this is confusing, please go watch my previous video. Or x is greater than 6. Okay, so, oh, sorry, I'm not supposed to write x. I'm supposed to write b. Sorry. Okay, so we know if b is less than -6, we will have two unequal but real roots. And if it's greater than 6, we will have two unequal real roots. Okay, the final case is if we have no real roots, and that is when b squared minus 4ac is less than 0. Okay, we've done all the groundwork. It will also be an inequality. So our b squared minus 4ac in this case is b squared minus 36. And it needs to be less than 0. Okay, so to solve this inequality, I've already found the CVs above and drawn the number line. And I see that for this less than 0, for this inequality, it corresponds with the middle portion of my number line because less than 0 means negative. So B is going to be in between -6 and 6 because it's sandwiched on the number line. Okay, so this is a basic version of the nature of roots. I'm now going to extend this question to a more similar format that we face in the question from the past paper. Okay. Sorry, I'm just having slight technical difficulty. So here we have x is equal to -n plus or minus the square root of n squared minus 4mp over 2m. All right, so I'm going to create a similar but slightly more simple scenario. Okay, so consider the root. Let me rather say root. Okay. Okay, I'm still not happy with this formula. Let me quickly edit it. Okay, no, this 4 needs to be under my root. Okay, consider the root for which values. Let me actually rather not use b either. I'm going to change this to f. Okay, for which value of f will this root be non-real? Okay, so a similar scenario to our question, but with a lot less unknowns and no geometric sequence involved. Okay, so for which value of f will this root be non-real? Okay, well, we know that roots are only non-real if b squared minus 4ac is less than 0. Okay, but if we look in our case here, they've already isolated x for us. And we don't really have we don't really have the situation where it's a multiplied by x squared plus bx plus c. So what do we do? Well, this format looks really familiar. In fact, the whole thing. X is equal to fraction with a root on it. It looks really familiar. Does it not look just quite similar to the quadratic formula? In this question, they've already applied the quadratic formula for us. and we need to analyze, and they found a root, okay? It just happens to have a variable in the solution. And they've told us, okay, this is a root we found. X is equal to -3 plus the square root of minus f plus 4 over 2. When will this root be non-real? Well, we know that we will have a non-real root if the bit underneath the square root is negative. So we simply need to solve -f plus 4 less than 0, because this is the term under the square root, and if that is negative, then we have a non-real root. Okay, and I simply am going to take my 4 over, becomes -4, and then I'm going to divide out by a negative, and my inequality changes direction. That always happens, by the way. Whenever you divide out by a negative and you do inequalities, it changes direction. And I see for f greater than 4, I will have a non-real root. For example, if f is equal to 5, which is greater than 4, I will have -5 plus 4 under the square root. So it will read my x is equal to -3 plus the square root of -1 over 2. And this square root of -1 is going to give me a non-real answer. So I see that I've done the right thing. This video is already quite long, and since the roots question involves sequences, I would actually like to finish this question in another video where I can also give a bit more of a background about sequences, and so that the videos aren't too long. Thank you so much for listening to this video. I hope you found it helpful.